Hello everyone, my name is Abhijit Reddy and today I'll be presenting my Dat301 Project 1 title on Titanic survival prediction. In this project, I analyzed the famous Titanic dataset using R to explore the survival pattern and build a predictive model that estimate who was more likely to survive the disaster. So the Titanic sank in 1912 after striking an iceberg and over 1500 passenger and crew member lost their lives. This tragedy has been studied extensively in data science because it contains both numeric and categorical features that makes it ideal for classification modeling. The dataset which I used is available through CRAN Titanic package, which mirror the original Kaggle Titanic dataset. It includes 891 records and variables such as survived, class, sex, age, sparge, fare, embarkment, etc. And the main question I wanted to answer here were what factors like sex, class, age, family, size, fare, embarkment port were most associated with survival? Can a simple logistic regression model predict the survival with reasonable accuracy or not? So here I began by loading the dataset into R using Titanic train. Then I used janitor clean name to standardize all variable names. To prepare the data for analysis, I performed several cleaning steps. I converted six class embarkment to factor variable, recoded the survive variable as yes and no for better readability, created new feature called family size, which adds the number of siblings, spouse, parents, and children traveling together. Next, I handled the missing values. For embarkment, I used the mode since only two values were missing, and for age, which had several missing entities, I imputed values using median age group by sex and class. Finally, I dropped high cardinality or sparse column like name, tickets, and cabin, which doesn't have much effect on the survival rate. And after cleaning, I verified that there were no remaining NA values, and I had 891 rows and 9 columns ready for exploration. And let's look at the exploratory data analysis section. Here, about 38% of passengers survived while only 62 did not. That means that survival was exception rather than rule. In the next chart, you can clearly see the relationship between the gender and passenger class amongst a female, especially in the first class. Survival rates were very high, well over 90%. For males, survival rate dropped sharply, especially in the lower classes. So gender and classes seem to be dominant predictors. And here, this histogram shows the age distribution of survivor versus non-survivors. Young passengers, particularly children, had high percentage of surviving, and also whereas older passenger tend to not survive. And fair versus surreal, when looking at fares, survivor who paid high fares, which often correlates with higher class tickets. However, the variation is large, so the fare alone isn't a perfect discriminator. This chart breaks passenger into solo, small, and large families. The pattern shows the people with small family had best survival rate, while solo traveler and large families had lower odd, probably because small groups could cooperate or fit into lifeboat more easily. Overall, the EDA gives a strong intuition like being a female, young, and first class passenger increased your survival chances dramatically. Based on those insights, I built a logistic regression model to predict survival. The predictors include sex, class, age, fare, embarkment, and family size. I split the data into 80% for training and 20% for testing, keeping the random seed fixed for reproducibility. And the regression results confirmed what the EDA suggested. The coefficient of male was strongly negative, indicating that male had lower odds of survival. P class 2 and P class 3 had significantly negative coefficient compared to first class. Age had a small but significant negative impact. Each additional year slightly reduced survival probability. Fair showed a mild positive effect. And when I converted the coefficients to odd ratio, being male reduced to the odds of survival by odds of factor of 0.06, while being in third class reduced odds by 0.36. These are large intuitive effects. Next, we also I evaluated the model on the test set. The confusion matrix shows a good predictive power. The model achieved about uh, okay, so the model achieved about 0.077 accuracy and about 0.70 precision. Recall is about 0.65. F1 score is about 0.71, and AUC of 0.836 indicates strong discriminative ability. The ROC curve on the right shows the true positive rate versus false positive rate. The closer the curve is to the top left, the better the classifier. Here, the model performs quite well for such a simple setup. In practical terms, this means the logistic model correctly classifies survival roughly 3 by 4th of the time. From the top predictor table, the most influential variable were sex, passenger class, age, fare, family size. So the main key takeaway is that social and economic status, along with gender and age, played a major role in survival. This align with the historical accounts that women and children are prioritized first, and the lifeboats were limited. The model accuracy of 77% and AUC of 0.83 shows that the model, despite being simple, capture most of the key patterns in this data set. Oops. Uh, So everything in this project is fully reproducible. I used the built-in data set Titanic train uh, from the Crane Titanic package, so there's no need to download any external files. All random processed use a fixed 042, and the complete markdown code is included in the submission. And knitting it will produce this PDF. To conclude this project demonstrates the end-to-end data science flow of cleaning data, exploring pattern, building a model, evaluating it, and interpreting the result. The Titanic dataset remain an excellent example of how a simple logistic model can yield a powerful, intuitive insight into human behavior. And also, thank you for watching my presentation.